Welcome to another episode of Terry's Notes, and today we're going to be looking at the January 2017 paper, question 4. Alright, so in question 4 we have two functions, f of x is equal to 4x minus 7 and g of x is equal to 3x plus 1 over 2. So the question wants us to find g of 0 plus g of 5. So the first thing we need to do is find g of 0. So we're going to take 0 and plug it into the function g. So it'll be 3 multiplied by 0 plus 1 over 2. 3 multiplied by 0 is 0 plus 1 over 2, which will give us a half. Then g of 5 is equal to, we're going to plug 5 into the expression for g. So it'll be 3 multiplied by 5 plus 1 over 2, which is equal to 15 plus 1 over 2, which is 16 over 2, which is equal to 8. So g of 0 plus g of 5 will give me half plus 8, which will give me 8 and a half. Alright, so the next part of the question asks us to find fg of 5. So this is a composite function here. So what we do, we find g of 5, and the answer we get, we're going to plug it into the function f. So g of 5 is equal to, we just worked that out. We got g of 5 is equal to 8. Now we're going to find f of 8, which is equal to 4 multiplied by 8 minus 7, which is 8 4 is a 32 minus 7, which is equal to 25. So therefore, f g of 5 is equal to 25. Now, in this one, we want to find f inverse of 1. So what is f again? F is 4x minus 7. So f of x is equal to 4x minus 7. Right, so first thing we do, we let y equal to 4x minus 7. Then we need to interchange x and y. So therefore we get x is equal to 4y minus 7. And the next step is to make y the subject of the formula. So we can write this over as 4x minus 7 is equal to x. Right? Therefore, 4y minus 7 is equal to x. So therefore 4y is equal to x plus 7. So therefore y is equal to x plus 7 over 4. So therefore the inverse of f is equal to x plus 7 over 4. And the question wants us to find f inverse of 1. So we just take 1 and substitute it into our inverse expression. So it'll be 1 plus 7 over 4, which is equal to 8 over 4, which is equal to 2. Alright, so the next part now. We have 2 points, P and Q, and they make a line segment PQ. So just for referencing, right, I'm not going to draw this accurately. So we're going to have a y-axis, our x-axis. 6 minus 1 is going to be somewhere here, and that is P. Q is 2, 7, so it's probably somewhere here. So this is Q. And the line segment PQ is this. So the first thing they want the gradient of PQ. So you, just by looking at the line, you know you should get a negative gradient. Right, and the gradient of a line, small m, is equal to y2 minus y1 over x2 minus x1. Right, that's straight formula here we're using. So we have 2 coordinates, so we can label the coordinates as x1, y1. This will be x2, y2. So y2 minus y1 will be 7 minus 1 over x2, which is 2, minus 6. Now all I'm doing is substituting into the formula here. 7 minus minus 1 will give me 8, and 2 minus 6 will give me minus 4, which will give me minus 2. So the gradient of PQ is minus 2. Notice we got a negative here, because we just by looking at the sketch, we can see that the line has a negative slope. Now midpoint now. The midpoint lies in the middle of the line segment PQ. So the midpoint is somewhere here, right? And which we can call that, let me call it big M, right? Not to be confused with the small m. So the midpoint of a line is given by x1 plus x2 over 2, comma, y1 plus y2 over 2, right? Because it's a coordinate we're trying to find here. So we already know x1 and x2, which is 6 plus 2 over 2, and minus 1 plus 7 over 2. This will give us 6 and 2, 8 over 2. Minus 1 plus 7 is 6 over 2. So therefore the coordinates of the midpoint would be 8 divided by 2 is 4, and 6 divided by 2 is 3. So the coordinates are 4, 3, right? Now the last part of the question wants us to find the equation of the perpendicular bisector of PQ. Now, what is a perpendicular bisector? We have the line segment PQ. The perpendicular bisector is a line that passes through the midpoint of PQ and is perpendicular to PQ. So this angle here is 90 degrees, right? Now in order to find the equation of a line, we need a point through which a line passes, and we need to know the gradient. So here's something that you need to know. When you have two lines, give a line here, and the gradient of one is small m1, and the perpendicular line, so this is 90 degrees here, is m2. For the lines to be perpendicular, m1, which is the gradient of one line, multiplied by the gradient of the next line, should be minus 1. We already know that the gradient of PQ is minus 2. Therefore, the gradient of the perpendicular bisector should be equal to a half, right? Because the gradient of PQ is minus 2, sorry. So therefore, minus 2 multiplied by a half gives me minus 1, right? So therefore, the gradient of the perpendicular bisector is a half, and we know that it passes through the point 4, 3. Right, so let me just go back to this page here. So we know that for the perpendicular bisector, it passes through the point M, which we got as 4, 3. And we know that the gradient of the perpendicular bisector is a half. So small m for gradient, it's a half. We know the equation of a straight line is given by y is equal to mx plus c. We know m is a half, so y is equal to a half x plus c. So our next step is to find what c is, and to do that we need to use a point that is on the line. So it's a coordinate, so therefore x is equal to 4 and y is equal to 3. So therefore, substituting into this expression here, we end up with 3 is equal to a half by x, which is 4, plus c. So therefore 3 is equal to a half by 4 is 2 plus c. So therefore c is equal to 3 minus 2. Therefore c is equal to 1. So therefore the equation of the perpendicular bisector, so we're coming back to this equation here, is equal to y equal a half x plus 1. Alright? So what they're saying is that, or the equation that we got is saying that the equation of this line here, this dotted line we drawn here, alright, is y is equal to a half x plus 1. Okay?